Okay, now we are going to look at this equation that has two radicals in it. So in this problem, we're going to have to square both sides twice. The first thing we need to do is isolate one of the radicals. So we'll isolate the square root of 2x minus 5, and we'll add the square root of x minus 3 on both sides. So we're left with the square root of 2x minus 5 equals 1 plus the square root of x minus 3. Now we're going to square both sides. When you square the left side, you just end up with 2x minus 5. When you square the right side, you have to FOIL it out. 1 plus the square root of x minus 3 times 1 plus the square root of x minus 3. So you're going to get 1 plus 2 square root of x minus 3 plus x minus 3. All right, I didn't go through the whole long thing of FOILing it out. You can do that. Now you add your like terms. So 2x minus 5 equals 1 minus 3 is negative 2. And then you've got plus 2 times the square root of x minus 3 plus x. All right, now you are going to get your radical by itself again. So you're going to get this radical by itself now. You're going to move everything to the other side. So I'm going to add 2 and subtract x, add 2, subtract x. So I'm going to end up on my left side with 1x minus 3. Sorry about that. Let me erase that. So that's just going to be x minus 3. 2x minus x is x. And then on the right side, you're just going to have 2 times the square root of x minus 3. All right, now you're going to square both sides of the equation. So, I think, we'll divide by 2 first to get that radical completely by itself. All right, now we square both sides again. So we're going to have x minus 3 quantity squared over 4 on the left, and we're going to have, forgot to cancel the 2's. We're going to have x minus 3 on the right side. All right, so now we are going to have to, I'm going to move us all the way up here. We're going to have to square out that binomial, x minus 3 times x minus 3, which is x squared minus 6x plus 9 over 4 times x minus 3 on the right, equals x minus 3. Sorry about that. Equals x minus 3. All right, I'm going to multiply both sides by 4 just to get rid of that whole fraction thing going on. So x squared minus 6x plus 9 equals 4x minus 12. I'm going to get everything on one side because we have a quadratic equation. So subtract 4x on both sides and you'll have minus 10x here. And add 12 and you'll have plus 21 equals 0. I know this is factorable because I can see that 21 is 7 times 3 and 7 plus 3 is 10. So I know I can factor it. So 7 and 3, subtract both of them and you'll get your negative 10 here and you'll get your positive 21 there. So these two things multiply together give you 0, which means that x minus 0 is 0, or x minus 3 is 0. So x is 7 or x is 3. These are the two possible solutions for the original equation. However, I'm not sure they both work, so let me go back to the beginning and check. I'm going to check x equals 7, put it into the original equation all the way back up there. So you're going to have the square root of 2 times 7, which is 14, minus 5, minus the square root of x, which is 7, minus 3, and that's supposed to equal 1. All right, so the square root of 14 minus 5 is the square root of 9, which is 3. 7 minus 3 is 4, so the square root of 4 is 2. And 3 minus 2 does equal 1, so x equals 7 does work. All right, now I'm going to need to go back and check 3. And since I don't have any room, I'm just going to go ahead and erase some of this stuff up here so that I have room, because I don't want to run out of room. All right, so now I'm going to check 3. X equals 3, so that would be the square root of 6 minus 5 minus the square root of 3 minus 3, which is 0, equals 1. That gives me the square root of 1 minus the square root of 0 is 1. 1 minus 0 equals 1. That is the truth. So x equals 3 also works. Both solutions work. All right, here we have a quadratic. We have a binomial raised to a power. You know what? This doesn't even have I'm going to have to check what that actual problem is, because that's not written correctly. Okay, so I'm skipping example C for the moment because I don't have my book with me and I don't know what that problem was actually supposed to be. So we're just going to move on here and do the next few things, and then we'll come back to that in another video at the end. So, solving rational equations and absolute value equations. The best way to work with a rational equation, the best way to solve it, is to first of all get rid of the fractions. At least that's the way I like to do it. And to do that, of course, you multiply by the common denominator of any fractions you have there. So I'm going to multiply this whole equation through by x times x minus 2, because those are the factors I'm dealing with. Factor of x and a factor of x minus 2. Now don't forget, this is x times x minus 2 over 1. If that helps you to think of it as being a fraction over 1, that might help you. But the whole purpose of multiplying through by that thing is to make all the denominators cancel. So if when you multiply through by it, you still have fractions, you have made a mistake. All right? So we're going to distribute it. We're going to multiply the first fraction, 2 over x, by x times x minus 2. When we do that, the x in the top and the x in the bottom cancel, and we're just left with 2 times x minus 2. Now we're going to multiply the 3 over x minus 2 times x minus 2. In this case, the x minus 2 on the top and the bottom cancel, and you're just left with 3x. And then finally, we have to multiply 1 by x times x minus 2. So there that is right there. Now all we have to do is use the distributive property and solve. Okay, so we've got 2x minus 4 equals 3x minus x squared plus 2x. Be sure you distribute that minus sign. It's a quadratic equation, so we get everything on one side. We will add x squared on both sides, and we will combine our like terms, and when we do that, everything will come out to be, it will be x squared, then you've got 2x minus 5x, so that's going to be negative 3x minus 4 equals 0. That is factorable. 4 times 1 is 4, and negative 4 plus positive 1 will give me my negative 3 in the middle. So if these two factors multiply together give me 0, it means that one of them actually is 0. So x minus 4 is 0, x plus 1 is 0, therefore x equals 4, and here x equals negative 1. So these are the two solutions that work in that quadratic. And they should both work in the original equation because we didn't add any solutions by squaring both sides. We just multiplied by some factors, so we didn't do anything that would cause us to gain solutions. So I can check them. 2 over 4 is 1/2. So if I check x equals 4, you don't have to do this because we didn't square both sides, but I will just show you that they both work. So that would be, if I put in 4 for x in my original equation, that's 2 over 4 equals 3 over 4 minus 2, which is 2 minus 1. So 1/2 equals 3/2 minus 2/2, and that's true. So 4 works. Check negative 1. I mean, it's good to check just to be sure you didn't make a mistake. So put negative 1 into the original equation. You've got 2 over negative 1 equals 3 over negative 1 minus 2, which is negative 3 minus 1. So negative 2 equals negative 1 minus 1, and that's true. So both of them will work, and there was no question that they would both work, because unless I had made a mistake. All right, to absolute value equations. To solve an absolute value equation, we have to set up two equations to consider all possibilities for the solution. For example, if x minus 2 is 3, think about it. What are the possible values of the expression x minus 2? Well, we know that when we take the absolute value of a number, it becomes just a positive number. It's just the distance of that thing from 0. So if the absolute value of x minus 2 is 3, x minus 2 could be 3, or x minus 2 could be negative 3. It can be either one, because the absolute value of 3 is 3, and the absolute value of negative 3 is 3. So there are two possibilities that you have to figure out. You have to get the absolute value by itself, and then you have to think of the two possibilities about what you're talking about. So x minus 2 could be 3, which would mean x would be 5, or x minus 2 could be negative 3, which means if you add 2 on both sides, that x would be negative 1. So these are the two possibilities that work in this equation, because 5 minus 2 is 3, absolute value of 3 is 3, and negative 1 minus 2 is negative 3, and the absolute value of negative 3 is 3. So when you're dealing with absolute value problems, you have to work with both things, both possibilities. All right?